Meeting should start recording. Okay, cool. So, today we're going to be continuing the presentation about data analysis. I'm assuming you guys were all there last time, so just open up the Kaggle note here. I'm going to do tab. So I'm going to open up my Kaggle. So let me just. So you should come. So when you go to Kaggle.com, you should come to the screen. Should look something like this. Then you click Notebook, and then you should click your work. And then we should have named it like this or something last time with this, and then you click Edit. So just tell me when you're there. It should look something like this. Okay, cool. So everyone has the last time's code, right? This stuff. Just say yes in the chat if you do. And then I know we can continue, otherwise we can get back to it. Okay. Justin, Brian, do you guys have it? Oh, okay. So for Brian, I'm going to send you this, and you can just yeah, so for Brian, you can just use this link, and then it should give you, let me double check. It should give you an option to does the link work? Brian? Oh, it doesn't work. Okay, hold on. Yeah, it's because link sharing is locked. Okay, cool. I'll have to make it public. Okay, save. Okay, so now try the link. Okay. So yeah, just refresh the page. Let me just make sure it works myself. Okay, so for Brian, what you can do is you can just click copy and edit, like on here. I'll just share. Yeah, so it should look something like this for you, and then you click copy and edit, and then you'll have to create an account and stuff, but it's free, or maybe not. Yeah, but oh yeah, you have to sign in. So yeah, and then just like change this name to like Helyx Data Science Intro or something. But yeah, and that's just my code. So okay, give me 1 second. Oh, it looks like someone wants to. Hold on, someone is. Okay, so we're just gonna continue on the presentation. So this is where we left off last time. So okay, last time we talked about line graphs. So like there's this like there's obviously a lot of different graphs as you saw in my COVID visualization in the document. But yeah, there's a lot of different graphs, and like one of them is line graphs, right? And that's like what we made last time. So are you always going to use line graphs is a question that a lot of data scientists ask. So are the following interpretations of the graph correct? A, the GDP of the country D has a similar growth as the other countries. B, from 1950 to 1970, the GDP of all four countries did not change much. Or C, from 1980 to 2010, GDP of country C grows much faster than that of country A. Or D, 1980 from 1980 to 2010, GDP of country A grows much faster than country B. You guys can try answering this if you want, but if not, like the main premise here is like we talked about this idea of like drawing conclusions, and like the reason we have data science is because like you want to draw conclusions from data. So this is just like how we draw conclusions. So this is like you could obviously see how this is like this could be useful in like an economic scenario where you're looking at whether a country's on the economic rise and like why that happened, and like so you can like replicate it and allow for more economic rises. So yeah, so okay, the next thing is uh we discussed this, and like there's also another feature that I didn't go over last time but yeah, we're gonna. So if you look at my screen now, I'm waiting for it to load. Yeah, 1 second. Okay, so um, then you could do another thing that's like plt dot plot. Gonna go years. Let's create a fourth GDP. That'd probably make this easier. Okay. I'm gonna create a fourth GDP data set. So if we call this GDP 4, this is like another country, then this would be like 1,100, 1,000. Oh, and then you have to add 0.0 after everything. I can send this in the chat, but this can be like 2,962.0. This would be like 1,280.0. This is like purely hypothetical, and then this could be like 9,034.0. And this could be like 15,500.502. And then this could be like 200,000, 20,000. Sorry, not 200,000. And then let's just make this one 5,080 so that we can have a clean line. So then you'd go GDP 4 because that's the data set, and then you'd want to go C, arrow like that. I don't know if it's 1 or 2. I think it's 1. Yeah, okay. Oh, no. Oh, it flipped it. Okay, yeah, it's this way. So you'll see what that means in a second when we run the notebook, but hold on. Give me 1 second. Okay, and then plt.legend. And then I'll also show you what this means, but for now you can just put it. So Okay. So I'm gonna do a quick version save so that we can give it a second. Okay, cool. Then we go here, run it. Oh, I forgot to. So you have to run all of them because this is the import. So you have to run all of them, all three. So yeah, now it should work. So now you can see you have your tiny legend here. You have the new little graph, and that's like a dashed line. So like a dash dot, and then it's like dotted lines. This is your solid line. Yeah. Um. Yeah. Okay. And then yeah. So as you can see, like legend makes stuff easier. And then so let's go back to the presentation. So a GDP of country D has, and then these are also some conclusions that people would look at. I'm not going to read them out loud because I don't want to waste time, but yeah. So this is the same graph. If you wanted to, you could do this, which is that you go down here and then you go plt dot ylim. Oh yeah, I mean, oh also for questions you can just ask the chat 0 to 1000. And if you run it, you'll see what it does. But yeah, essentially, it restricts it from 0 to 1000. So that's like it restricts the y limit or like the y range. So I'm pretty sure if you go plt xlim, then you can go 0 to 1000, and that won't do anything. So 0 to, let's just say we want to only get data from 19 to 1980. And then you should see, yeah, it cuts it off, right? Because it limits the x-axis, and it limits the y-axis. But we'll delete that for now. Okay, cool. The next thing is, again, there's always these conclusions at the bottom that we're gonna go over later. So next, you can change your scale. So we're gonna be here. Okay. Yeah, so the next thing is you want to change your scale. So you want to make it a logarithmic scale. That's like a big common theme in data science. So you'd start off by going semi-log y years, comma GDP1. I won't go into the too much like math of this, but yeah. Oh, someone is trying to join. Okay, so the next thing is bo dash, and you always have to remember to run your notebook, run like whenever you want to rerun it, after this class or something, you have to run the entire thing. Give me 1 second. Okay, I have to add a student, so okay. So the next thing, yeah, so then you want to go like just regraph this entire thing essentially. So years, comma, GDP3, comma, and then the next thing would be GD, as we talked about in the last class. this is just the same 4 graphs that you want to graph, and then the new one, which is years, comma, GDP, 4, comma, C, yeah. I usually like to do that, but yeah. And now you run this, and it should work. Yeah, okay. It's just a little messy because my data points aren't as good. So the data points just like intersect at points. But if we were to go, so then the next thing you want to do is like add a title and make it better. So add title, which is like nominal GDP. And then you could be like, add a Y label. So it's just plt.y label, billions of dollars. Where's dollar sign? Okay, plt dot x label is, you want to say it's a year because that's what we defined it as, and then you could add your legend. If you want, you could copy this here, right here, for some time's sake. Okay, cool. So it's good to see more people are here. But yeah. So then the next thing you want to do is country D. That's the 4th GDP that you want to add. So that's like on the legend. And then you want to show the plot so that you can see it visually. And there you go. So now it's like better, right? And now this would be easier to analyze points from. But yeah, there you go. That's a plot for you. Yeah. I think I messed up the red dot. Hold on. Oh, I didn't. Yeah. Yeah, okay, that's fine. Yeah, that's my bad. So I accidentally forgot a colon here, which is for dotted lines. And so if you run it again, then you're going to see dotted lines here. So yeah, this is like on a logarithmic scale. You don't really need to know what that is, I guess. Not really, not yet. But as you can see, like the scale is different. So if I was to compare it to, let me rerun this one. But yeah, this one is like, you know, like these smaller amounts, but now you get to like the bigger logarithmic amounts, which is to base 10. Okay, so the next thing is going to be here. So this is mainly about like line graphs, so that's what we're going to be discussing for the majority of today, and then we're going to move on to scatter plots, etc. So line graphs are useful to display trends, and that's why people use them. But if the trend is really random, then and you always want to like make sure that your line graphs are used to display trends over mainly time, I'd say. But the x-axis can always change. So yeah, here's some different plots. If you take a look at these, and I think that this is like a good validation of like plots. And for essentially the big idea of line graphs are like displaying trends. So now we're going to use some bar charts, and then I'm going to go back here. So you can just create a new cell here, and so movies, we can do movies example. I'm going to send you guys the data sets because I don't want you guys to type it all out. So copy. So everyone check the chat and then copy that into your new cell here. And then tell me when you guys are ready. So just say like ready or something in the chat. Are you guys all ready? Okay, I will send out the notebook because I don't want to, stop. But is everyone ready? Here, Athena, I'm going to send you. So click on the link above, and you should see the new notebook. Athena, and tell me when you guys are all good. Is everyone ready to move on? Okay, cool. So, so you're trying to display numbers. So movies versus number of Oscars per movie. So the first thing I would try to do is hold on. Yeah. So okay. Yeah, so the first thing I try to do is x's equals range. So now you're trying to get the range of it. Yeah. So this should give you this should give you 5. So the reason it's going to be range of 5 because there's 1, 2, 3, 4, 5 elements in this, right? So yeah, and then you'll see why that comes into handy later. But the next thing you'd want to do is so you want to plot bars with left x coordinates and heights as so the x's should be your left x coordinate and your height should be the number of Oscars that each movie got. So the reason we're gonna try to like do bar plots now, my bad. So it's the same process as so it's the same process as the line charts in terms of the first value is your x-axis, the second value is your y-axis. So you want to go, and then if we were to plot it now, it won't look good, but it's something. So now you see that this movie 0, or in this case would be Anna Hall, has 5 Oscars, right? Because that's what this says. So Anna Hall has 5 Oscars. Ben-Hur has 11 Oscars. That's why it has a higher thing and near the 11th axis. And this Casablanca, or the third movie, has 3 Oscars, and then you can see that here. And yeah, so you can like continue and you'll see that it matches up with all the data. But now you always want to like make your data descriptive. So first thing you're going to do is label your x-axis, which is going to be what's a good oh yeah, you can do x ticks. Yeah, okay, that works. So now this is what a lot of people do, which is that they change the ticks each, the 0, 1, 2, 3, 4. You'll see when I run this changes to the movies that correspond to it. So this is just like a depiction of what happens like on the compiler level. But yeah, now you can see the specific movies and how many Oscars it has. So the next thing you can do is and then also there's another way that you could just like make these 2 lines one line, which is if you go content.plt dot bar x's comma num Oscars ticks underscore label equals what would you want to call yeah so tick label I don't know why I said ticks, but yeah, tick label equals movies. So now if you run it, you get the same exact thing. and it's just in one line. So this is what I usually do, but this is also unacceptable and something I learned as a basic. Okay, the next thing is going to be plotting is changing your like graph and like making it more sophisticated. So your Y label is going to be number of Oscars per, that slash is per movie, and then the x-axis is going to be, the x-axis is going to be, I mean, just movies, right? That's what I would say. Okay, and then if you want to go plot dot show, and then you'll see your plot. Usually you don't have to do that if you're programming on Kaggle, but it also does remove the output layer. But yeah, this is what it'll look like. You see your movies label down here. You see your Oscars label up here. And yeah, so you got yourself a little graph and a bar chart. So why are bar charts good? Why do we use bar charts? So I'm going to share my screen on this one. Okay, so yeah, bar charts are good for representing or comparing like numbers in different data sets. So in this case, right, like you wanted to see like which one's the highest, which one's the lowest, which one's like right in between, and this is like a clear depiction of what happens. So yeah, now we're going to talk about bar H charts or bras charts. Okay, next thing is BRH plot. So if you go plot bar H, then you go, can you see my screen? Okay, yeah. Plot bar H, X's, comma, number of Oscars, comma, tick, underscore label, equals movies. And that's just so you can, yeah. So now, whoops, it's not number of Oscars. It's, sorry, I forgot the variable, but yeah, it's num Oscars. My bad. Okay, so you can see how it like tilted it, right? Essentially just flipped it on its side. And it's the same data representation, but it's just in a different format. Like if you were to compare it to the last one, it would basically be the same, but let's put some labels on it to make it better. So if you, okay, let me just do this. So let's say we put that label, right? Number of Oscars per movie in movies. That's not right, right? You want your movies up here and your number of Oscars. That's why you'd like flip these. So this would be X, this would be Y. There. Yeah. And then, so yeah, now you flip these two. Okay. The next thing, so yeah, if you were to compare it to like, if you were to compare it to this one, they're the same thing. It's just like different depictions. So this is usually used for larger data sets. This is usually used for smaller data sets. Then again, this could be used for larger data sets too. So now I want to do something which is like showing you guys, you know, the difference between bar plots and these line graphs, right? So let's just say I was like PLT, let's make a bar chart out of you know, this one, right? Out of the nominal GDP example. So you'd start out with your so well, you'd use the same data, right? So let's just do one GDP1. Okay. Yeah. So GDP1, and then you would do, you can just copy these things up here. Or these things. Yeah. Run it. Should show here. Yeah. So this is a bar chart for a GDP1. This had adjustion though. Like usually Kaggle auto adjusts, but usually in this case you'd want to use a line chart because as you can see here, you can more clearly draw interpretations from this side of data. So like a direct line straight up is probably more easier to read than this. And plus you can't do too many bars on this one. So like it's not that easy. And like you'd have to like really think about where the points are because like they're not clearly labeled, and it's just a mess on the bar chart, but on the line chart, it's a lot easier. So this is like a clear example of like, always look at your scenario and always try to determine, what happens based on that. But more examples of bar charts are histograms, which I'll discuss later. So this is like a histogram. That's like a type of bar chart. More advanced bar charts or bar charts with multiple groups will also be discussed later when we get to pandas. So next is scatter plots. I did one for COVID. So, but this one is, I'll show you guys all of these, and after we get back to the COVID example. So that has a little different code, by the way, so that'll look different. But yeah, okay. So for this one, right? So let's just say you want to do what's a good data set? Okay, so let's just say friends equals here, I'm just gonna copy the data set here. Okay, this is from my old data science lecture, but yeah, here is the data set. So look in chat and copy that into your notebook like so, and then you want to go. Now you want to make a scatter plot. So simply enough, you just go plt.scatter, and then you make your x-axis, your y-axis. I think that's, wait. No, I flipped it. Yeah. No, wait, no, that's fine. Yeah, it works. So here's a scatter plot of minutes versus friends. So that's like how many minutes, how many contacts do you have in a minute or per minute, like after a certain number of time. So now let's go through and label each point. This is where it gets a little more complex. So if you guys remember for loops from our previous Python reviews and stuff, when friends, so you want to go through every single friend that you have and you want to label it, right? So PLT, so Matplotlib has this cool feature known as annotate, where you can essentially label your points. So then you want to iterate through this labels list. So then the next thing you want to do is inside here, xy equals so this is like each xy point. So you want to get access to each xy point, and then you want to say where do you want the text to be placed on the label. So you'll see this when you run it, but yeah. And then how do you want the style of the text coordinates? So you want to say, I think I usually go offset points, if I remember correctly. Yeah. So then you have each point labeled. Now you just want to run it. So now you can see each point is labeled. You got your G down here, your D, F, H, and these all correspond to each data set here. Yeah. So the next thing you want to do is make it, you always want to, like, this is one thing I always do, but it's always like labeling your data set. So you go plt dot title daily. So this would be like what you're discussing, minutes versus number of friends. That's what I would write. And then the next thing would be an X label, which is number of friends. And then this would be Y label, which is I think, yeah, just minutes or daily minutes or daily, let's just say like it's a site or something. You could say daily minutes on site. on, texting or something. Anything works. But yeah. Then you can click run up here, and then you get your labels. So this one down here, and this one up here. Okay. Why not do friend and friends? I mean, yeah, you could do that too. So if I was like, I usually just do I usually, oh wait, you have to change everything. Yeah, well, friend is like also a lot like longer to type. So I just chose I because I didn't want to waste too much time. But yeah, this would work too. I guess it's more specific, but it's the same thing. I usually just use I because it's like a lot more efficient in terms of like typing and stuff. So why are scatter plots good? The scatter plots are good because, as you can see here, you can visualize two different sets of data on one plot and see how they interact, which is like really useful when you get to the world of data science. So similar to the line plot, the axis of scalar of scatter plots can auto scale. So you saw that in the previous examples with the GDP. And then you have your X limits, your Y limits, that's like limiting how much you want, and or axis limits, which is just, your like general limits. Or yeah, you could force equal a range. And then a very a famous example is like test grades for scatter plots. So usually it'd be like student by grade, but this is different for some reason. But yeah. So the next thing is just reviewing functions. So this is like creating figures with numbers is if you guys want to try it out, it's plt dot figure 1, figure 2, figure 3, figure whatever to specify which figure to plot on. So like creating that's like useful when you want to plot like a bar chart and something else next to each other. So if I were to go here, I usually don't use a figure chart because usually in my work I use like two different screens or something, but plt dot I don't know if it works on Kaggle. Yeah, it does. Okay, but yeah, it created two because like on Kaggle it's different, but yeah, that's how it looked. Okay, then the next thing is xticks, which is making your, like we did with the movies example, the y ticks, you could do the same thing on the y-axis. Save figures is like, like saving it, but again, Kaggle is different and you don't have to do that in Kaggle. So I think if I'm correct, that is it for this presentation. Okay, so let me pull up my next one. Give me 1 second. Just need to pull up my slides. This is weird. Okay. Give me 1 second. It's loading. Okay, so we're just going to do a quick preview of the next time. You're going to see like linear algebra, but don't be scared because it's like not, and we're not going to go over that too much in depth so that it can be accessible for everyone. But yeah. So we're just going to do a tiny preview so that I can go back and review some stuff. Okay. NumPy, this is what we're going to be talking about next time, which is that you have a lot of data and essentially you use NumPy to create different arrays. So I'm going to skip through this so that we can get through. And then we're going to go over lists, different data types in NumPy, and then vectorizing and array slicing. Then we're going to go over reshaping. We're not going to do all this math. And then, yeah. So next time is going to be a pretty math heavy slide, but don't worry, I'll try to I'll make it as simple as possible because, yeah. Okay, so let us get to reviewing. So as I said before, okay, so what you want to do also before you go is if you click save version and then here type in 6-2, then you can click save, and then now your output is going to save. Now your output's going to save, so let it like load and then we'll move on from there. Yeah, so one more thing is like after we finish all this data science stuff, we're going to start working on some mini projects. So ask your friends, start advertising Helix Studio so that we could have more mini projects. I'm going to take a quick second to talk about our research camp. Okay, so I'm going to send more about this in the email, but if you go to helix.science/camp, we're hosting a research camp this summer, and I will be teaching at it, and so will all of our, like a lot of, expert researchers. And here's like a sample of our schedule and what we're looking to do. So you start off by learning basic biology, and then from there you start applying it into Python and things like that. And then we'll get to some more advanced things, which are like using Python to detect diseases. And then we'll have a presentation for your parents to watch. It's only $88, which is relatively cheap for any research camp, and anyone can join. So just go to the page, helix.science/camp, and then you can ask us a question, and you could register here, and then here too. So yeah, there's some, and if you can't afford the $88, there's some financial aid that you could apply for, and we will try to help you out. So it's pretty merit-based for the financial aid, and it's proven need too. So please, 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 if you really want to come to this camp but need financial aid, please feel free to apply. And yeah, so that leaves me with like a few minutes left in class. So I'm gonna quickly go over the COVID notebook that we talked about at the beginning when we first talked about data science, and just show you, how much you've actually learned. Okay, so yeah, this is a data science notebook that I put together. If you weren't here for the first time, we're going to go over it. So yeah. So yeah, this is a COVID-19 data science notebook I put together, and I'm working on a project. So I, took some work from my project into here, and it's a research project with UCSD. It's a data analysis project, and yeah. So right now we're looking. This is some basic COVID stuff I did, and I was like, I might as well share with Helyx. So yeah. Yeah. So essentially, like, this is all the data reading. This, you haven't done this yet because we haven't discussed pandas, because we haven't been using like loaded in data sets, but we will do that. This is all pandas functions, and yeah, so essentially, like, this is like an example of how uh, a bar chart or histogram, or a special kind of histogram, or a special kind of bar chart is used. So this one describes birth year versus frequency of disease. So as you can see, there's like different gaps in diseases, and this is what the data we're looking at for COVID is. This isn't live streamed, so this was made in 3 months ago. So this is from 3 months ago. This is a root line chart. So for this one, again, right, this isn't like a bad example of a line chart. So you have your two random lines, but like, what conclusions are you going to draw, right? So a line chart is not a good use in this one, and there's just so many better uses of charts in this one. So yeah, this is describing, we'll talk about that when we get to pandas. This is your scatter plot. So I thought this was cool because it's time of confirmed diseases versus time of confirmed deaths. So as diseases keep getting confirmed, how long is like the gap way between number of diseases confirmed and the increase in deaths, right? So this is a good use of a scatter plot. The next is the correlation between the flu and the coronavirus. So as you can see, the larger end have coronavirus, and it's like spread out. But yeah, there's also definitely better uses for flu versus COVID data. But yeah, okay. Are there any questions I can answer right now on Python, data science, or anything we discussed today? Any Helix stuff? Anything? Just type it in the chat if you have any questions. I don't want to start a new unit right now because we'll be interrupted, and we have to get going. So if you want to get going, that is perfectly fine with me. If you want to stay, ask questions, or want me to go back to something that you didn't catch, then yeah. No problem. I will see you guys on Saturday, hopefully. Athena, I will send out the notebook so you can look at it, just in case you missed anything. Yeah. It'll be in the email. Yeah, no problem. I'm gonna send it in the email and then put it on the doc. So I'm gonna send out an email. Yeah. Okay. If there are no other questions, are there any questions? Code related, anything else? Okay. So I will put together a quick review doc and send it out tonight. I will see you guys. Yeah. I'll also put it in the doc. Saturday, same time. No, same time. Yeah, 4 p.m. Correct. 4 p.m. to 5 p.m. Yeah. Tell anyone you know to come, and register for Helyx tutoring so that you have more people when you start working on the mini projects. But yeah, I will see you guys later. Have a good day, everyone.